Hello, I am Dr. Arpitha from Mathematics Department, VJEC. My topic is now linear algebra. Solution of system of linear equations. Here I have considered the system of equations a1x plus b1y plus c1 and a2x plus b2y equals c2. Most probably the system of equations having the three types of solutions. One is unique solution, infinite many solution and no solution. So when we are going to say they are setting have the unique solution, whenever the system of equation they are going to intersect at a single point, then the system of equation we are having the unique solution. Suppose the system of equations they are intersecting a infinite number of points, they are going to have the infinitely many solutions. And if the system of equation they don't intersect, they are having the no solution. In the first case, this is the one straight line, this is another one, it is intersecting one point, so they are going to have the unique solution. This is a one straight line, and the straight line is also coinciding on itself. So the two straight lines are lying on oneself. They are coincident. In this case, they are having the infinite many solution. Suppose they are the two straight lines. They don't have any point in common. Otherwise, we can say that they are the parallel lines. In this case, they are having the no solutions. So here we can observe that three types of solutions: unique solution, infinite many solution, and no solution. Okay, whatever I have explained in the first slide, here the brief explanation. The two lines are intersected at one point. They are said to be consistent and no unique solution. Here the lines are constant. They are having infinite solution. In this case, the lines are not constant. They are parallel lines. We are going to say that as inconsistent and have no solution. Right? Now, these are some examples related to the unique solution, infinite many solution and no solution. So, if we solve this one, first one, if we solve this equation, what we are going to say? X plus y equals to 3 and 2x minus y equals to 3. Simplify. 3x equals to 6 and x equals to 2. Okay. If we substitute this x value in first equation, we are going to get y equals 1. In this problem, what we can observe, the x value is 2 and y equal 1 is a unique solution. This is one case. And if we come this equation, x plus y equals to 1, if we take common here 2, x plus y equals to 2. So, let us observe clearly the first equation, second equation, they represent same. So, the two equation nothing but they are single one equation only. So, x plus y equals 1 and second one also x plus y equals 1. If we solve this one, we are going to get infinitely many solutions. We are having only one equation. Even though we are having the two equations, they are both are same. So, in this case, the two lines are coinciding each other. So, we are having infinite solution. If we come across this example, x plus y equals to 3 and x plus y equals to 5, we don't get any single solution, so that x value and y value, if we substitute, the equations are going to satisfy. So, in this case, we don't get any solution, that is no solution. So, we have seen here no solution and infinite solution and unique solution. Now, solve the system of equations. So, previous this one, we are having the system of equations, homogeneous type and non-homogeneous type. Homogeneous type means whenever we are having in the system of equation right side some values are there, non-zero coefficient, non-zero matrix, then we are going to say that is a non-homogeneous equation. If right side values are zeros, then we are going to say that is a homogeneous type. Now, I am going to discuss the system of equations with respect to the non-homogeneous type. Whenever we are going to find the solution of the system of equations, first of all, we have to write the given system of equation in matrix form. That is, here A equals to what I am going to get? 1, 1, 1, 2, 5, minus 2, 1, 7, minus 7. Okay. And what is the coefficient matrix? X, Y, Z. And matrix B equals to 4, 3, 5. Okay. Now, first of all, we have to write the given system of equation in matrix form Ax equal B. Right. Now, in order to solve the system of equations, we have to consider the augment matrix A, B. What is the meaning of this one? We have to write in the matrix A along with the B. This is nothing but 1, 1, 1, 2, 5 minus 2, 1, 7 minus 7. Okay. 4, 3, 5. This is the argument matrix. Now, in order to find the solution of the given system of equation, our main duty is that we have to reduce this matrix into echelon form. You know very well that what is echelon form? The first row element must be non-zero and the number of zeros must be in increasing order, and the rank of the matrix is nothing but number of non-zero rows. This is all the property of the echelon form. Now, first of all, we have to make the second row and third row as zeros, that is R2 implies R2 minus 2R1 and R3 implies R3 minus R1. What we are going to get? 1, 1, 1. Okay. 4. R2 minus 2R1. 2 minus 2, 0. 5 minus 2 is nothing but we are going to get 3. Minus 2 into minus 4. Right? R2 implies 2 minus 2, 0. 5 minus 2 is 3. Minus 2 into minus 2 is minus 4. 3 minus 8 is nothing but minus 5. Okay. 3 minus 2 into 4 is minus 8. 3 minus 8 is minus 5. Similarly, 0, 1 minus 1 is 0, 7 minus 1 is 6, and minus 7 minus 1 is minus 8, and 5 minus 4 is nothing but 1. Okay. What is the condition? That the number of zeros must be in increasing order. Again, R3 implies R3 minus 2R2. Right? What we are going to get? 1, 1, 1. 4, 0, 3, minus 4, minus 5, 0, 0 minus 0 is 0, 6 minus 6, 0, right, minus 8, here we are having minus 8, minus 2 into minus 4, that is nothing but plus 8, we are going to get 0, right. Next, R3 minus 2R2, R3, 1, minus 2 into minus plus 2 into 5 is 11, right. Let us consider as equation 1. This is 1. Now, what we can observe, if we consider the left part, that is represents the matrix A, and the total part we can consider the matrix A and B. So, number of non-zero rows in matrix A, that is echelon form, rank of the matrix A is 2. Number of non-zero is 2. And what is the rank of the matrix AB? Number of non-zero rows 3. Right. Rank of A is not equals to rank of augment matrix, right? If whenever the rank of A is not equals to rank of augment matrix, what we are going to say? This is the system is inconsistent. What is the meaning of the inconsistent? It has no solution. Okay. So we have solved the system of equations, that is the non-homogeneous steps, and we have reduced the given that argument matrix echelon form, and we got the rank. And what we are going to observe, that rank of the matrix not equals to rank of the argument matrix, then we are going to say that it is the inconsistent. So whenever the system is inconsistent, the system is said to have no solution. So we don't get any x, y, z values, so that the system of equation is going to satisfy. Or else we can say that the system of equation, they represent the parallel lines. Suppose this is a line, this is a line, this is a line. So there is no intersection between the lines. So whether we are going to get any solution for these parallel lines? No. So this is here the system of equations having the no solution. This is the first problem. Another one, this is the solving a system of equations. What is the first step we have to write? The system of equation we have to write in the matrix form. Okay, Ax equals to B. What is A here? 1, 2, minus 1, 3, minus 1, 1, 2, minus 2, 3. Okay, x value is x, y, z, and matrix B is 3, 1, 2. Right. I have written the given matrix, given system of equation in matrix form. Now, what is the argument matrix I have to write here? Argument matrix is nothing but 1, 2, minus 1, 3, minus 1, 1, 2 minus 2, 3, 3, 1, 2. Right? Now, what is our duty? That we have to reduce this one into echelon form and find the rank. Okay. R2 implies R2 minus 3R1 and R3 implies R3 minus 2R1. Okay. Now, this is nothing but what we are going to get? 1, 2, minus 1, 3, 3 minus 3, 0, minus 1, minus 6, nothing but minus 7. Okay. R2 is minus 1. R3 is minus 3 into 2. Minus 1, minus 6, minus 7. 1 minus of minus 3 into minus 1 is 4. Okay, right? R2 1. 1 minus 9, minus 8. Okay. 2 minus 2 into 1 is 0. R3 minus 2. Minus 2 into minus 2 is minus 6. Then 3 minus of minus 2 is 5. Right. Here R3 is 2. 2 minus 6 minus 4. Okay. What is the condition that we have to, the number of zeros must be increased. R2 implies, right, R3 implies 2 minus 2 is 0, minus 2 minus 2 minus 6, 3 minus of minus 2 is 5, right? 2 minus of minus 2 means 2, minus is minus 4, right? Now, the number of zeros must be increased. R3 implies 7 R3 minus 6 R2. Okay. Now, why we are applying this one? In order to, the number of zeros must be in increasing order. So, in the third row, the number of zeros are 1. So, we have to make the third row, the second element as 0. That's why we are applying this one. What we are going to get? 1, 2, minus 1, 3, 0, minus 7, 4, minus 8. Naturally, this is a 0. Minus 6 into 7. That is nothing but 42. Minus 2 minus is 0. Right. 7 into 5. 35 minus 6 into R2. That is nothing but 24. What we are going to get? 9. Okay. 24 means 11 here. 11. Now, 7 into R3. 7 4 is 28. Minus to minus plus. 6 into 8. 6 is 48. We are going to get 20. Right. Now, is it in echelon form? Right. This is in echelon form. The number of zeros are increasing order. And what about the rank? Rank of A equals to rank of argument matrix equals to number of variables equals to R equals to 3. Now, whenever rank of A equals to rank of our argument matrix, then we are going to say that is a consistent. And in addition to that, the rank is equal to the number of variables. So, what we can say here? Consistent. And what about the solution? Unique solution. Okay. Now, let us consider this one as 1. Now, how we are going to solve the unique solution? From the equation 1, we can write the system of equation like x plus 2y minus x plus 2y minus z equals to some 3 minus 7y plus 4z equals to minus 8. Okay. 11z equals to 20. Now, so from equation 1, we are going to be able to write that equation 1 as in terms of the equations. Okay. Now, from this, what we are going to observe? Z equals to, what we are going to get? 20 by 11. If we substitute this value of Z in equation 2, we are going to get Y value. After getting the Y value, if we substitute in equation in 1, we are going to get X value, Y value, Z value. Okay. Now, what is my main intention here? That so I have solved the system of equation. I have written the given system of equation in matrix form. Ax equal b. After writing the Ax equal b, I have written the argument matrix. The main duty of us argument matrix is that we have to reduce argument matrix in echelon form by applying the row operations. What is the condition in row echelon form? The number of the first element in the first row must be non-zero and the number of zeros must be in increasing order. So, is the condition is satisfied? Yes. First element is non-zero element and second row number of zeros is 1 and third row is number of zeros are increasing. Right. This satisfies the echelon form. And what is the rank of the matrix? Rank of the matrix A is 3. Rank of the matrix is AB is 3. How we are going to find the rank of the matrix here? The number of non-zero rows. In A is number of non-zero is 3. In AB is number of non-zero is 3. So, whenever rank of A equals rank of argument matrix, it is said to be consistent. In addition to that one, the rank is equal to the number of variables. In the equation, we can see that number of variables is 3. So, we can say that it is consistent and unique solution. Now, how we are going to solve the unique solution? From 1, we are able to write that one in as a system of equations. So, if we solve this equation, we are going to get the x value, y value and z value by backward substitution. Last one, we are going to get z value. With the help of the z, if we substitute here, we are going to get y value. With the help of the With the help of the y value, we are going to get x, y, z value. So in this way, we are going to get the solve the system of equations. So this is the way to solve the system of equations by reducing into echelon form and finding the rank. Most probably what we are going to observe, we are having the three types of solution: unique solution, no solution, and also infinite solution. No solution means inconsistent. Unique and infinite means consistency, and two types is unique and infinite solution. So this is a way of solving the system of equation, especially non-homogeneous types, and the way we are solving is applying the echelon form and finding the rank. Okay, this is all about the linear equations of solving the non-homogeneous system of equations and types of solutions we are going to get, and how we are going to able to get the solutions of the problem in case of the non-homogeneous, unique solution, and also infinite solution. Right. Thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.